In this video for Positive Maths, we're going to look at the 2010 sample paper. It's paper 2, question 8. So the first thing that we do when we see a question like this, we're going to read it all the way through. Then we're going to read the question again and highlight key information. After that, we're going to make a note of any important details. These are usually the numerical details. And then we're going to check and see that the diagram has all of this information. So do we need to add anything onto the diagram? Okay, so two surveyors want to find the height of an electricity pylon. There's a fence around the pylon that they cannot cross for safety reasons. The ground is inclined at an angle. They have a clinometer for measuring angles of elevation and a 100-meter tape measure. They've already used the clinometer to determine that the ground is inclined at 10 degrees to the horizontal. So part A. Explain how they could find the height of the pylon. Your answer should be illustrated on the diagram below. Show the points where you think they should take measurements. Write down clearly what measurements they should take and outline briefly how these can be used to find the height of the pylon. So after that, we're given a diagram with our 10 degrees. We're given space to write the measurements to be taken. We need to write down the procedure used to find the height. So let's continue on and read part B for this question. Write down possible values for the measurements taken and use them to show how to find the height of the pylon. That is, find the height of the pylon using your measurements and showing your work. Okay, so now we're going to go back through and we're going to underline the key information. So they want to find the height of the pylon. There's a fence around the pylon that they cannot cross, so we can't forget that. The ground is inclined at an angle. They have a clinometer for measuring angles and a 100-meter tape measure. They've already used the clinometer to determine that the ground is inclined at 10 degrees to the horizontal. So really 10 degrees is the only piece of numerical data that we're given. Okay, if we look at part A, again we're asked to explain how they could find the height of the pylon. And really to do this we need to do three different things. We need to illustrate it on the diagram. We need to show the points where the measurements are taken, and we need to write down clearly what measurements they should take and outline how they're actually going to find the height. So the diagram, the measurements to be taken, and the procedure used to find the height. Now, we saw in part B what they actually want us to do is to fill in information, so give certain measurements and use the measurements that we suggest to find the height of the pylon, or to show how we can find the height of the pylon. So what you might find for these types of questions is that it's actually more straightforward to do part B first and then go back to part A and explain the procedure that you used to find the height and the measurements that you took. Because sometimes you might not know straight away exactly what measurements and exactly how to do it. Sometimes it's through working it out that you find your way. So we are going to use the diagram, but we're going to fill in these extra parts after we do part B. So the diagram is really going to be the key part of this question. The first thing I'm going to do is I'm just going to draw a red line all the way down through the pylon to show the height that I'm actually finding. Now I'm going to draw in the height of one of the surveyors, and now the angle of elevation from the first point. Okay, so I'm going to fill in my angle of elevation. And again, to make it more straightforward for myself, I'm going to use certain measurements. So my first angle of elevation, I'm going to say is 30 degrees. So what I want to note now at this stage, that my total height that I'm looking for is actually made up of two different heights. So we have the height of the surveyor, I'll say is H1, and then the rest of the pylon, which is h2. So I'm going to note at this stage that we're going to use the tape measure to measure the surveyor. So we're going to say h1 is equal to 1.75 meters. Again, this is just really an average height of a person, and we would use the tape measure to find this. So the tools that we've used our clinometer to find the angle of elevation, and we've used the tape measure to find the height of the surveyor. So I'm going to draw a rough sketch to help me with the next part. So I'm going to draw out my triangle. Okay, so I know I have a 30-degree angle here, and I cannot find this distance that I'm marking with X. So I'm going to put in the letters A, B, and C just to help me to identify different points. Okay, so we're looking for the distance CB. So that's our H2. We're looking for that distance. So in order to find that, we're going to need to find the distance AC, because we cannot find the distance AB. So if we have AC, then we can use sine rule to find CB. So let's just consider that. In order to use sine rule, I need the other angles in the triangle. So the first thing that we want to note is that the angle here is 100 degrees. So let's consider that. When we have a right angle triangle, which we usually do have for most of these types of situations, we have a right angle. But we're told in this question that we have an incline of 10 degrees. So if I just look back over to the diagram, if I put in a horizontal line there, that's my 90-degree angle, so 90 degrees, plus I have an incline of 10 degrees, so it makes the angle ABC 100 degrees. So therefore my angle up here is going to be equal to 50 degrees. So I might not need to use all of these angles, but by filling them in, it'll help me to see, can I use sine rule, can I use cosine rule, or how we're going to find missing sides. Okay, so if we look, we have all the angles in the triangle. We're looking for H2. We cannot find AB, but we can possibly find AC. Okay, so the plan is really, if we look at what we have, if we had AC, then we could use sine rule. So we could use 30 degrees and 100 degrees. We could use AC to find BC. Okay, so our next task then is going to find this measure. So the next thing we're going to do, we're going to go back to the diagram. We're now going to get our surveyor to move further down the hill and measure another angle of elevation. So we have a point D. This angle of elevation, because it's further away, it's going to be a bit less. So let's say it's 20 degrees. And now we have another triangle. So let's draw a sketch of this triangle. So I have 20 degrees. I'm noting that if I have a straight angle here, and that's already 30 degrees, then my angle here is going to be 150 degrees. So I have 20, 150 gives me 170, and my angle up here is going to be 10. So again, I might not need all of these angles straight away, but they might help me later on. So if we look at this triangle that we have now, we have the triangle DCA. Let's consider what sides we can find here. So we can find the measure from D to A, that length, because we have our measuring tape. So let's put in a distance. Let's say that's 10 meters. So we want to remind ourselves, we want to find AC, because then we can use AC to find BC, which is what we're looking for. So in this triangle, we can find AC. So we have all of the angles and one of the sides. So therefore, we can use sine rule to find AC. So we have the angle 20, we're looking for AC. We have the angle 10, and we have the corresponding side 10 meters. So our sine rule tells us if we have A over sine A, it's equal to B over sine B. Okay, so our side A is going to be AC. So we'll leave that as A. So A over the sine of 20 degrees is equal to B, which is going to be 10, over the sine of 10 degrees. So therefore A is going to be 10 multiplied by the sine of 20 degrees over the sine of 10 degrees. So if we go to our calculator, we'll find that A is equal to 19.6962. And because we have 10 meters, that's going to be 19.6962 meters. So now we have AC. Again, we can use sine rule to find BC. So again, A over the sine of A is equal to B over the sine of B. We need to just be careful that we are using the correct angles and sides when we're doing this. So this time our A is going to be our side BC. So it's A over the sine of 30 degrees is equal to B, which is 19.6962, over the sine of 100 degrees. So therefore A is going to be equal to 19.6962 multiplied by the sine of 30 degrees over the sine of 100 degrees. So again, we're going to go to our calculator. So we're going to find that A is equal to 10.00002282. So we don't need this many decimal places. We're going to round, we usually round to 4 decimal places until we get to the end. But in this case, we're just going to find that A is equal to 10. So we've now found that H2 is equal to 10, and again, that's meters. So the last part then, the total height is going to be equal to 1.75 plus 10, so that's 11.75 meters. So now that we've found the total height, that's what we were looking for, let's go back and recap and then go back and do part A. So we started off at the point A. We measured the angle of elevation and we said it was going to be 30 degrees. So the next thing we did was fill in other information. So we know that that's 100 degrees and not 90 degrees because the ground is inclined at 10 degrees. So therefore we can also find this angle up here. So it's 50 degrees. So we know that we cannot find the distance AB. So we need AC in order to find BC. So that's what we have to do. We have to find AC. To do that, we had to kind of create another triangle. So we moved the surveyor back to the point D. We found another angle of elevation. Therefore, we could also fill in some more angles. So we have 150 and we had 10 up here. We can also find the distance between D and A. So we use our tape measure to find that that's 10 meters. So now that we have that other triangle, the triangle ADC, we can use sine rule to find AC. So we found that to be approximately 19.62 meters. And then we use that distance AC and sine rule again to find H2. And we found that that was 10 meters. The last step then was noticing that we're looking for the total height. So 10 meters plus 1.75 gives us 11.75 meters. So having done part B, part A will now be quite straightforward. So we've done what we needed to do on the diagram. So the first measure that we're going to identify is H1. This is the height of one of the surveyors. The next thing we did was we found the measure of the angle BAC. So this is the angle of elevation at point A. Then we found the measure of the angle ADC. So we'll say this is our second angle of elevation at point D. And the last measure we found was the distance DA. which is 10 metres. So H1, we're going to put in 1.75 metres. These are the measurements taken. The angle BAC, 30 degrees. The angle ADC, 20 degrees. And the distance, we have 10 metres. Okay, now let's go through the procedure that we used to find the height. So we used sine rule to find AC, and we'll even say using the triangle ADC. Then we use sine rule to find BC using, this time, the triangle ABC. Then find the total height. So we'll say H1 plus H2. So again, you'll see now how it can be easier to write down the measurements taken and the procedure after you've actually done it. For more information, visit PositiveMaths.ie, email us at info@PositiveMaths.ie, and follow us on Facebook and Twitter. Thanks for watching.